This is the 10th behavioral design pattern from the Gang of 4 Design Patterns book. This one is called Template Method Pattern, and it is a pattern you use when you want to capture the structure of an algorithm in a template method and defer the implementation of particular substeps of the algorithm to subclasses. I will start with a quick summary of what we are trying to accomplish with this pattern. The template method pattern is a good choice when you are trying to accomplish the following. You have a group of algorithms that all consist of the same discrete steps. The algorithms differ only in the implementation of specific substeps. You want to transparently exchange algorithms without having to change the client code. Let's go through the points one by one. So the key intent here is that you have a group of algorithms that you need to use in your application architecture. The algorithms all share the same sequence of discrete steps, and they differ only in how they implement specific steps. You want to use the algorithms in client code, but you need the freedom to swap one algorithm out for another without the client code breaking. The template method pattern provides the solution to this scenario. It allows you to define the overall structure of the algorithm in a top-level template class and override specific substeps in derived classes. This architecture gives you a lot of freedom. The top-level class defines the number and order of individual steps, and may even provide a default implementation for each step. The derived classes can override any step they want, and can even replace a step with an empty method to effectively switch off an algorithm step. The benefit of the template method pattern is that it provides a very compact way to implement a group of related algorithms. All the shared code of the algorithm goes into the top-level template class, and only the corrections related to a specific algorithm go into the derived classes. The template class provides a generic interface to the algorithm that completely masks the implementation. Therefore, you gain the freedom to swap one algorithm out for another without breaking the client code. Here is the UML diagram of the template method pattern. The algorithm is defined in the abstract class in a public method called template method. The method implements the algorithm by performing a number of discrete steps in order. Each step is encapsulated in a separate method called primitive operation X. All primitive operation methods are protected and virtual. The template class can either provide an overridable default implementation, or implement the operation as an abstract method that must be implemented in a derived class. The diagram shows a very simple algorithm that only uses two primitive operations. These operations are implemented or overridden in the derived concrete class. You can see in the diagram that the derived class provides an implementation for the primitive operations and doesn't need to change anything in the template method itself. Okay, I am going to use the template method pattern to create a class that appends data to a file on disk. However, there's a catch. The file on disk is encrypted. So this process involves three primitive steps: decrypting the file, appending the data, and re-encrypting the file. I will set up a template method that implements these three steps by calling three primitive methods called decrypt file, append file, and encrypt file. The append file method has a default implementation, but the encrypt file and decrypt file methods are abstract and need to be implemented in subclasses. I will provide two subclasses for handling DES-encrypted and non-encrypted files. So, I will implement the pattern with the following classes. Let's take a look at the code. Here is the abstract base class called FileWriter. It declares the three primitive methods called decrypt file, append file, and encrypt file. The append file method is implemented and appends data to the file. But the encrypt file and decrypt file methods are both abstract and need to be implemented in subclasses. And here is the template method, simply called append. You can see that it performs all three operations in sequence: decrypt the file, append data to it, and finally re-encrypt the file. And here are my concrete classes. The DESWriter class implements the decrypt method and uses DES decryption to decrypt the file. The method writes the decrypted data to another file called temp.txt. And this is why I must also override the append file method. It cannot append to the original encrypted file, but must append its data to the new temporary file called temp.txt. And here is the encrypt method. The method takes the temp.txt file as input, encrypts it using a DES encryptor, and writes the encrypted data back to the original file. Now compare this to the other concrete class called unencrypted writer. Here the decrypt file and encrypt file methods do nothing, and so the class will only process unencrypted files. There is also no need to override the append file method because the default implementation is fine here. And finally, let me show you the main program method. you can see that I have two files, encrypted.txt and unencrypted.txt. I first use a deswriter instance to add some text to the file, and then I use an unencrypted writer to do the same for the non-encrypted file. Okay, before I run, let's take a look at these two files. Here is a file manager window with the debug folder of the application. Here is the unencrypted file, and you can see that there's a single line of text in here. The encrypted file contains the exact same text, but it is desencrypted. When I open the file, you can see that the contents are completely unreadable, just as we would expect. Now, let me run the program to prove that everything is working. I'm compiling the code now. And I'm running the program now. Okay, no errors. So let's look at the files again. When I open the unencrypted file, you can see that another line of text has been appended to it. And when I open the encrypted file, we still cannot read the contents. But you can still tell that a line of text has been added, because now there is a lot more encrypted text than before. Okay, here is a quick checklist you can use to implement the template method pattern. First, identify the algorithm and decide which steps should be deferred to subclasses. Then create an abstract class with a template method that implements the structure of the algorithm. Add abstract methods for each substep that must be deferred to subclasses. Implement the substep methods in one or more concrete classes. And finally, have clients instantiate the correct concrete class and call its template method. And here are some final comments. The strategy pattern is very similar to the template method pattern, but the difference is granularity. The template method pattern defers substeps of an algorithm to subclasses, while the strategy pattern defers the implementation of the entire algorithm to subclasses. You might also notice a similarity between the factory method pattern and the template method pattern. The two patterns differ in intent. The factory method pattern modifies how new objects are constructed, whereas the template method pattern modifies how an algorithm operates. Okay, let's recap what we have learned in this lecture. The template method pattern lets you capture the structure of an algorithm in a template method and defer the implementation of particular substeps of the algorithm to subclasses. The pattern provides a very compact way to implement a group of related algorithms. The template method pattern is very similar to the strategy pattern, but differs in granularity. The pattern is also similar to the factory method pattern, but differs in intent.